Okay, so a very good evening to all. Uh, can anyone verify? Are you able to see the screen and is the voice clear? Am I audible?
Yes, yes.
Okay, thank you. So let us begin today's session. So this is the live session number 10, and in today's session we are going to see the optimization, the basics of optimization. In the last session we have seen the power distribution planning, and we have seen the economic aspects in power distribution system. We have seen what is the future and present worth of uh, any means any component or element, and we have solved problems based on that. And we have also seen the mono object some the basics of optimization, and in that we have seen mono objective optimization problems. And in today's session we will mainly focus on the multi objective optimization and what are the solution strategy for that, and then we will solve some of the problems based on that. And this session will be totally theoretical. There will no numerical problems based on this optimization. We will just solve the theoretical problems. So now we are at the end of this course. Almost we are at the end, and now there are two sessions more left. That is session number 11 and session number 12. And if it required, then at the end I will also take one revision session. That is not fixed, it may be happened. So let us just see. We have also seen some of the basic slides for optimization, and in today's session we will also starts from there only. So what is optimization? Optimization means that we are either maximizing or minimizing certain objectives which can be translated to some mathematical function that are called objective functions. And these objective functions can be of single objective optimization function or multi objective optimization function. If you look on this objective optimization function, so as the name says, it is having single objective function, and that is this one is just one of simple, and it can easily solved, and we can easily get the optimal solution. So for single objective optimization function, we are either minimizing or maximizing one objective function, where this x is called decision vector, which consists of a number of decision variable, optimization variables, problem variables or variables. So this x is having various names. It is called decision variables, optimization variables, problem variables, or variables, or simply variables. And now again, if the function is a if the function is if the objective function is only single one, then we call a single objective optimization function. And if this based on this variable that we call a decision vector, if this x is a single variable, then we call a single variable objective function. And x may be of n dimensional vector, like x equal to vector of x1 x2 x3 so on xn. So this we called it as multivariable objective function. So we have seen this single objective optimization function. You can easily define what is called single objective optimization function. Single objective optimization function in which that consists of single objective function. Now we will move to multi-objective optimization function that consists of m number of objective functions f1, f2, and so on till fmx. So this contains more than one objective function that we call as multi-objective optimization function. And now, in order to solve this optimization problem, in order to minimize or maximize this multi-objective optimization function, there are some constraints that should be satisfied. So when we are solving some optimization problem, then we are have to follow some constraints, and these constraints should be satisfied while minimizing or maximizing the optimization function. And the constraints may be of equality in nature and may be of inequality in nature. So uh, one the constants can be of equality constants and or inequality constant. So equality constants, like here, that is where this equal sign is denotes like this function equal to 0, or it may be have some certain value, or if inequality sign comes in the constant, then that is called inequality constants. So we will see what are the equality constants and inequality constants. So inequality constants, when we are having this power balancing, then we take it as equality constants. And when we are having voltage constants, means node volt, no, there should be some range for node bus voltage deviation, or some radiality constants that comes under inequality constants, while power balance comes under equality constant. So for single objective, that we see single objective optimization function, it is also called as multi-object mono objective optimization function. So this single objective we also name it as mono objective optimization function. So we have seen we have seen the definition for single objective optimization function and multi objective optimization function. Now let us see more in detail about single objective and multi objective optimization problems and their solution strategies. So for single objective optimization, you can define it is of two types, unconstant and constant. For both single objective or multi objective, you can having there are two types, like unconstant and constant optimization problem. Unconstant means there are no constant applied to the objective function. Here if you see the first one, unconstant optimization problem, where we have to minimize or maximize fx, and there are no constraints applied to this objective function. Means the aim is to just you have to get the optimal solution, you have to get the solution for this optimization function fx without any constant applied in the problem. While this constant optimization problem, there are some constants need to be satisfied while getting the optimal solution for the optimization problem. Like here, we are having to minimize or maximize fx, and we need to follow some constraints, and that is we need to follow some rules. This should must be satisfied while getting the optimal solution. The constants are simple, means like this constant need to satisfied while solving the problem, while solving the optimization problem. While in a constant optimization problem, there are no rules or there are no constants that need to be satisfied. So now in constant optimization problem, the solution which satisfy the constants are called feasible solution. So if anyone asks you what are feasible solution, then feasible solution are those solutions when you are solving the constant optimization problem, then when this solution satisfy the constants, that we call it feasible solution. And the best feasible solution in view of the objective function, that we call it as optimal function. So there are many solutions for this optimization function, but those solutions we satisfy the constraints that we call it feasible solutions, and among the feasible solutions, the best feasible solution in view of the objective function, we call it as optimal solution. So the innermost is optimal solution, then the feasible solution, and the topmost is just solution. So among various solutions, those satisfy the constraints that we call it as feasible solution, and among feasible solution, the best feasible solution, we call it as optimal solution. And the optimal solution can be of two types: local optima and global optima. So local optima is called the best solution among its feasible neighborhood solution, that we call it as local optima, while the best solution among all feasible solutions, that we call as global optima. So local optima, from the name you can from the name it also says that it is the best solution among its feasible neighborhood solution, while this global optima, the best solution among all the feasible solution. Today this Microsoft Teams is not working, so I have logged in through this website. If you are having any problem while going through the slides, means like if you are not able to see or any problem happen, then you just interrupt me, or you can type it in the chat box. Now coming to this multi-objective optimization problem, as I told you, this involves more than one objective function that are need to minimize or maximized, and that we represent like this: minimize or maximize f1x, f2x till fmx, that contains m number of optimization function, and these are constant to some equality constants or inequality constant. And for this multi-objective optimization problem, answer is the set of solutions that define the best trade-off between competitive objectives. So there is some trade-off between the objective functions, means when one objective function is minimizing, other may not, or other objective function may or may not be minimized or maximized at that variable. So there is some trade-off in this multi-objective optimization problem, and we will take the best trade-off between the competitive objectives. So in multi-objective optimization problem, the goodness of solution is determined by the dominance. So here, what are the difference between mono-objective and multi-objective optimization? So the objective function for power distribution planning, like the cost and reliability, generally conflict with each other. So that we call it as multi-objective optimization. So this cost and reliability objective functions generally conflict with each other for the power distribution planning optimization problem, and there exists a set of trade-off solution for the problem with conflicting objectives. When the cost is high, then reliability is low. So sorry, the cost is high, the reliability will be also better. So there exists a set of trade-off solution for the problem with conflicting objectives, and the set of trade-off solution can be obtained with simultaneous optimization of all objectives. So for this multi-objective optimization functions, this mono-objective optimization cannot perform this simultaneous optimization of multiple objectives. So here we need to perform simultaneous optimization of these multiple objectives, this cost function and reliability objective function. So therefore, this multi-objective optimization is required for such type of optimization. So mono-objective optimization cannot perform simultaneous optimization of multiple objectives. So how do we do the simultaneous optimization? So simultaneous optimization of the objectives is done using the Pareto dominance principle, and this strength Pareto evolutionary algorithm to SPEA2, a multi-objective algorithm, is used to extend PSO to multi-objective PSO. So this strength Pareto evolutionary algorithm 2 is a multi-objective algorithm that is extended particle swarm optimization to multi-objective particle swarm optimization. So this is they have Sir has shown this strength Pareto evolutionary algorithm to based optimization strategy for the solving this multi-objective optimization problem. So this SPEA2 MOPSO can be used for both static and expansion planning. So SPA2 MOPSO is a strength Pareto evolutionary algorithm 2 based multi-objective particle swarm optimization. Now you can understand in better way how this multi-objective optimization function are conflicting with each other, and how we have to get the Pareto based solution, like where we have to they are non-dominated solutions, and the solutions are there should be trade-off while solving this optimization function. So here you can we have taken an example where this optimization problem with two objective functions, where this objective function 1 is f1x equal to x square, while objective function 2 is f2x equal to x minus 2x 2 whole square. So these are unconstrained single variable optimization problem with two objective function. So these are single variable optimization with two objective functions. Since the variable is single, now our goal is to simultaneously optimize both the objective function. So we have to minimize fx equal to f1x plus f2x. So if you see in this range, when we are having the lowest of f1s, then this f2x is having highest of f2x, while in at the other point, when we are having this lowest of f2x, then at that point it is highest of f1x. So within these points we have to choose the optimal, choose the solution. And beyond this point, like beyond this y-axis, both f1x and f2x are in decreasing trend, so we will not get the solution. While beyond this dashed green line, both f1x and f2x are in increasing trend, so we also not choose the solution beyond this point. So within this point we have to we can determine the solution. So in this range, we can make the plot where we have made the plot f1x versus f2x, and we can and the curve is like this one, and the plot will be something like this, when f1x is increasing, at that time f2x is decreasing, and when f1x is decreasing, f2x is increasing. So this type of plot we call it as non-dominated solution. So what are the solution approaches for multi-objective optimization problems? These are weighted aggregation approach, Pareto based approach, and epsilon constant approach. So in weighted aggregation approach, we have weight to objective functions, and these weights can be denoted as w1 w2. So here this optimization function f1x equal to w1 f1x plus w2 f2x. So different combination of w1 and w2 is taken to find the multiple solution. And in epsilon constant approach, we have this minimizing this multi objective optimization function f1x f2x till f1x, where we have minimizing f1x, and this in another objective function there will be some epsilon This objective function for that range, this should be less than or equal to some small value that we denote as epsilon. Now the most be used for solving this multi-objective optimization problem, that is Pareto based approach. So this is one of the widely used method for solving the multi-objective optimization problems, and that was proposed by Professor Pareto. And in this, the goal is to simultaneously minimize, like here we are having minimizing total cost and total interruption cost for the power distribution planning optimization problem. And these functions, these objective functions, have constants of like equality nature. For equality nature, we are having the power balance constants, and inequality constants, we are having this capacity constants of substation or thermal limit of line, or then we are having voltage limit constants at nodes. So these are inequality constants. Now how you will see this Pareto optimal solution? So this Pareto optimal solution, this non-dominated solution set, these are non-dominated solution set. And what are these non-dominated solution sets? So we are having a set of solution. The non-dominated solution set is a set of all the solutions that are not dominated by any member of the solution set. So the non-dominated set or solution of the entire feasible decision space is called the Pareto optimal set or solution. So this Pareto optimal solution, so these are feasible decision space for the variables, for the decision variables, and these are if these map to this feasible objective space, then we make it this Pareto optimal front. So the boundary defined by the set of all of point mapped from the Pareto optimal set, we call it as Pareto optimal front. So these are feasible decision space, and when we map these two feasible objective space, then we call it as Pareto optimal front. So here two things are important. What are Pareto optimal solution? These are set of non-dominated solutions. And what are these called as Pareto optimal solution? These non-dominated solution sets are called Pareto optimal solution also. And if you map this Pareto optimal solution in the function range, then these are called as Pareto optimal front. And we have seen these types of optimization problem based on various methods, based on linearity, convexity, differentiability, and based on the nature of decision variables. So based on linearity, we are having linear and nonlinear optimization problems. Based on convexity, we have convex, non-convex optimization problems. And based on differentiability, we are having differentiable and non-differentiable optimization problems. And based on the nature of decision variables, we are have continuous optimization problem, discrete optimization problem, and mixed integer type optimization problem. So if you classify the solution strategy for the optimization, then there are two types: mathematical logic based algorithms and meta heuristic algorithm. So in mathematical logic based algorithm, we will have mixed integer programming, branch and bound, Bender's decomposition, dynamic programming, nonlinear programming. And the major drawback of this mathematical logic based algorithm is that they suffer from the curse of dimensionality, while for meta heuristic algorithms, this contains expert system, branch exchange, network flow programming, simulated annealing, and another set is population based meta heuristic algorithms, and this contains genetic algorithm and colony optimization, artificial immune system, and particle swarm optimization. And the drawbacks for meta heuristic algorithm is that convergence is not always granted. So In summary, for the solution strategy of multi-objective optimization problems, in midst of the multi-objective planning, the population-based meta-heuristic algorithms are used because it is having this multi-point search that helps to obtain a set of Pareto approximation solution in a single run, and they can handle nonlinear, non-convex, non-differentiable problems effectively, and they also don't suffer from the curse of dimensionality. So mathematical logic based algorithms, they suffer from the curse of dimensionality. So that is major drawback for solving for solving for solving the optimization problem that contains so many variables. So these meta-heuristic algorithms, they don't suffer from the curse of dimensionality, and the major drawback for this population-based meta-heuristic algorithm that the convergence is not always granted. Now these are all for this solution strategy for the these are all about the optimization part. Now we will see the configuration of power distribution networks. So till here, if you have any doubt, you can ask, otherwise we can move forward. So two people are only present today, Gutu and Divya. Okay, so let us come to the next part. So I think there are some problems based on this reconfiguration of power distribution network are not in this today's in this current assignment. Otherwise, most of the problems in week 11 that are based on the reconfiguration of power distribution network. So what do you mean by reconfiguration of power distribution network? So reconfiguration is to change the topology of a network. So here reconfiguration may be varied by manual or automatic switching operation, and the change in network configuration is performed by opening, sectionalizing switches or tie line switches. And sectionalizing switches, we know it is of normally closed type, NC type, while tie line switches or tie lines is of NO type, that is normally open type switches. So the two things we have to make in mind while doing the reconfiguration power distribution networks, while doing the while solving the optimization for problem, while doing the reconfiguration power distribution networks, that are all demands shall be met during reconfiguration. You don't you don't have you don't need to uh, you don't need to set up some load while doing the reconfiguration optimization problem. So all demands shall be met during a reconfiguration, and the reliability of network shall be maintained. So these two things be can act as a constant. So all demands should be so shall be met during configuration, and means demand should be as it is, means no load should be interrupted before and after the reconfiguration of power distribution network, and reliability of network shall be maintained. You cannot change the topology of the network. It should be radial in nature, means earlier it is also radial in nature, and after doing the reconfiguration it will be again radial in nature. You should not change it to like mesh type or another topology type. So for reconfiguration of power distribution networks, where we have solve optimization problem, we will solve optimization problem for this turning on or off this sectionalizing and tie line switches. So for that also we will see the optimization approaches. So here sir has also shown the various optimization approaches or solution strategy while solving this reconfiguration optimization problem. So optimization approaches can be of these four types: artificial intelligence based approach, and then heuristic based approach, and then meta heuristic based approach, and then mathematical optimization based approach. So in artificial intelligence based approach, we are having firefly algorithm and fuzzy algorithm. In heuristic based approach, we are having trial and error method, and meta heuristic approach, we are having this unique or population based meta heuristic approach. So in unique meta heuristic based approach, that we also call it call it as point to point search technique. And unique meta heuristic based approaches, that is of two types: taboo search or simulated annealing. While this population based meta heuristic approaches, this is multi-point search technique. So meta heuristic approach can be of two types. One is of unique type, that is point to point search technique, while other one is population type, that we call it as multi-point search technique. So this population based meta heuristic approach, that is most nowadays being used and widely known, and these terms are more familiar with all of you. Like in population based meta heuristic approaches, we have evolutionary algorithm, particle swarm optimization, colony optimization, and harmony search algorithm, then artificial bee colony. And in evolutionary algorithm, we are having two types: genetic algorithm and evolutionary programming. Now the last one is the mathematical optimization based approaches, where that is also called as determinist optimization based approaches, and example are LP, QP, and NLP. I think so. LP is linear programming, and QP is quadratic programming, and NLP is nonlinear programming. So that I am verifying. So in the reconfiguration of power distribution networks, again this optimization comes, and there are solution strategy. You can divide into these types. And for power distribution planning also, this is same. This optimization approaches, you can also call it as same, because these are solution strategy that you can apply in any application. So now I think so this we called. So put the reconfiguration at the end, because this is the next part, and there are some problems based on this CLLI. So we will see CLLI. So multi-objective planning incorporating sectionalizing switches and tie line switches using a new reliability indices. So the objective is to formulate a new reliability index that we call it as contingency load loss index. And here the objective is to incorporate placement of synchronizing switches and tie line switches into the planning, and to optimize number of feeder routes number and location of sectionalizing switches, tie-line switches, while multi-objective optimization. So you can refer this Sanjeev Ganguly sir paper where they have done work based where he has introduced contingency load loss index. I just forgot to put the as a reference, but you can take the reference from the big big 10 lecture number 26. So these are objectives of his work for his research paper, and he has introduced contingency load loss index. So this CLL is defined as the ratio of average non-delivered load due to failure of all branches considered one at a time to the total load. And minimization of CLLI is that maximizing the reliability of a network. So this is very important. When you are minimizing the CLLI, that denotes the maximum reliable network. And CLLI, as we have defined, it is the ratio of non-delivered load due to the failure of all branches, and we have considered one at a time to the total load. So the total load that is feeding through substation we denote as L total, and NDL average that we have taken the non-delivered load due to failure of all branches. And if you see, then you can take it as like we are considering one at a time, means failure of one branch at a time, and then we will see the non-delivered load, and then we take the average of that, then we call it as NDL average. So here NDLI are non-delivered load due to contingency at branch I, and NB is the total number of branches in the network. So let us take one example where a substation is feeding uh, feeding the loads L total, and loads are connected at this point 2 and node 2 and node 3. So let us take this contingency happened at this branch between node 1 and node 2. So substation is taken as slack node. So contingency happened at this point, that is between slack node and node 2. So if the contingency happened at this point, then the load interrupted. Due to that, we call it as NDL1. And now suppose the contingency happened at this branch that is connected between the node 2 and node 3, then we call it as NDL2. Now we have to take the average of non-delivered load. So NDL1 plus NDL2 upon NB. NB the total number of branches. So here there are three nodes. Three nodes means there are two number of branches. See, three nodes. Three nodes means number of branches will be 2. So number of branches equal to number of nodes minus 1. So NDL1 plus NDL2 upon 2 is the total, is the average of non-delivered load, and total load connected is L total. So this is the expression for this example. Now what is the range of CLLI? The range of CLLI comes between 0 and 1, and if the CLLI is 0, then we call it as best reliable network, because that denotes that wherever this contingency happened, non-delivered load is very minimal. So that we call it as that we can denote by this best reliability. And when this CLI comes as 1, that means worst reliable network, means all the loads are impacted by the contingency happening at any branch. While this best reliable means if this contingency happened at any branch also, this power supply to the load continues, and the power supply to the customer is not interrupted. That denotes that reliability of network is improved. So if CLLI is 0, that denotes the best reliable network, and that is impossible. That is very impractical. So we don't count 0, so that's why it is a small bracket, while one is within the big bracket, that denotes it can be counted, where maybe some contingency happened, then all the loads will interrupted and no power supply happen to the customer. And if the CLLI is 1, that denotes the burst reliable network. So now again, take one example based on this CLLI computation. So here, in this example, two distribution networks with 6 nodes of equal power demand. So at all the nodes, one is the slack node that we call as substation node. So this first one is slack node or substation node, slack node or substation node. And these 6 nodes of equal power demands means all the nodes we are having 100 kVA peak demand. So this all nodes, this all 6 nodes 100 kVA peak demand.
Sir, sound is not clear, sir. Please unmute, sir.
Sound is not clear. Now it is okay. Guddu. What means like some okay, thank you for just telling me, because there are some options we can do, otherwise the recorded version will also not be good. And the screen is visible or not? A screen is okay.
Screen is okay, sir, but the sound is not clear, sir.
Sound is not clear. I think I'm not able to open to the Microsoft Teams. Okay, because you're, I think from your side could do maybe with maybe some, because your voice is also not coming clearly to us. So I think maybe your network problem. You again log in, because for Divya it is clear for her. So let us continue from that point. So today, in today's session, we have theoretical problems only. So just focus on the concept, and then you will easily able to solve the problems within 10 minutes, because you uh, don't need to have pen and paper. So here we are having slack node or substation node, and then these are 6 nodes that are feeding power of 100 peak demand, 100 kVA peak demand. So this figure denotes a single distribution feeder distribution network, and the A1 denotes thus without sectionalizing switch, and B denotes the sectionalizing switch. So we know that sectionalizing switch is of normally closed type. So here in the second section, in the B part, we have taken sectionalizing switch, while in network A we have taken the section without sectionalizing switch. Now we will find the CLI of network A and B both, and this denotes circuit breaker. This cross point denotes circuit breaker. So both are 7 node feeder. One is slack node, a substation node, and 6 are load nodes where this 100 kVA peak demand is occurring. So here you can write one point. The only difference between these two feeders is that there is sectionalizing switch at feeder 2. So there are two sections. Here you can see one section that contains 2, 3, 4, while section 2 that contains 5, 6, 7, and in section 2 we are having sectionalizing switch. So it is denoting for this figure. It is telling about this figure. So here you can tell it as section 1. Section 1 we call it as upstream section, while section 2 is called as downstream section. So for network A there is no sectionalizing switch. While for network B there are two feeders or two sections, and in first sections there is no sectionalizing, while in section 2 that contains sectionalizing switch. Now we will find the CLI for both network. Now for CLI for network 1, for network 1, then if any interruption happened, since there are no since if any interruption happened at any line, like suppose interruption happened at this line, then 600 kVA peak demand is 600 kVA of power demand will interrupt. If any interruption happened this point, the same thing happened. If any interruption happened this point, same thing happened. If any interruption happened this point, same thing happened. Like all the 600 kVA load demand will interrupted. So for network A, this CLLI of network 1 is network A is 600 into 6 upon 6. So we know the CLLI. CLLI is NDL average upon L total. So this expression we are applying. So now if we see for this this feeder, this network B, then for this part, if what it called, if contingency happened at this line, then 600 load demand will interrupt, means all the load demands will interrupted. And for this line also, if contingency happened at this line, this all load demand will interrupted. And if the contingency happened at this line, all the load demands will interrupted. So that's why we have taken 600 into 3. Now after the sectionalizing switch, in section 2 we have sectionalizing switch. Now if we have contingency happened at this point, then you can open the sectionalizing switch. So this only 300 kVA load demand will be interrupted. And for this line also only 300 kVA load demand will interrupted. And for this line also only 300 kVA load demand will get interrupted. So you can see that before the sectionalizing switches, if any contingency happened, all the load demand will get interrupted. So that's why we have written 603. And after this sectionalizing switches, because sectionalizing present in section 2, only 300 kVA load demand interrupted, because we can open this normally closed switch. So these are this sectionalization we will open, and this will not get interrupted before the sectionalization. Like the load at node 2, node 3, and node 4 will be get supplied, even the fault or interruption, even the fault or contingency happened beyond this sectionalizing switches. So that's why we have taken 300 to 3, that whenever the contingency or fault happened after the sectionalizing switches. And 6 is the number of branches, and L total is 600 kVA. So you can see that CLLI of network A is 1, while CLLI of network B is 0.75. So for network A, we can say that this is worst possible value of CLLI, because CLLI varies from 0 to 1. And for network B, it is coming as 0.75 due to putting one sectionalizing switches in the network, and this value shows the reliability of feeder 2 or reliability of network B Reliability of feeder 2 is better as compared to feeder A. Sorry, I have by mistake told about this feeder is section 1, section 2. So this is the single feeder. So we call it as feeder 1, this one. The first one we call it as feeder 1, while the second one is the feeder 2. So this is a single primary feeder. So there are no feeders. So by mistake, I told you that section 1 is one other feeder and section 2. So just sorry for that. The single feeder. So feeder 1 is the top figure, while feeder 2 is the bottom feeder. So any doubt till here? Otherwise, we can move forward to the problem solving session. Okay. If you don't have any doubt, then we can move to the next problem solving part.
So normally CLLI optimization problem, will it be a maximization or minimization problem?
No, CLI is not about optimization. CLI,
Can we use this as objective function? No.
no.
Okay.
Sir has just formulated one reliability index in his paper that we call as condensing load loss index, and by this reliability index, he has shown that how the reliability improves for the power distribution network. This is not the optimization problem.
Okay, sir.
This
Okay.
is not optimization function.
Okay. Okay. And means normally we go for minimizing CLLI, right, sir?
Yeah, that is the desired one.
Okay. 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 That's what is it out.
Yes. I may be wrong because these are he has mentioned objectives of formulation. Means like that he wants to minimize. You are correct. Means when we are minimize this CLLI, then we are having this best reliability network. So, but I have not seen. Means it is not general. It is has been introduced in his paper, so that's why it is not usually find in the textbook. But he has taken this CLLI also as objectives, like 3 objectives to incorporate, to formulate this reliability index CLLI, to incorporate placement synchronization and to optimize number of feeders. So third one is the optimization function, while these two are like one is the placement of synchronizing switches and one is formulating this new reliability index. But I think whatever you are saying, the means like you can have one optimization function that you want to minimize CLLI, but you have to check whether how we will define this objective function based on these decision variables. Okay, just you check it, and then but one thing is clear that minimizing the CLLI means you are improving the reliability of network, because we have seen one example where this network be the more reliable by putting one sectionalizing switch in the feeder, and that is having lower value than network A. So coming to this problem part, the first question that evolutionary algorithms can be used to solve which of the following optimization problems? and the options are these things. You can put your answer in chat box. And this problem is, I think, of multiple select question. So there are more than one option can be correct. Multiple select question. A option is nonlinear problems with linear as well as nonlinear constant. B option is nonlinear problems with only linear constants. C option is linear as well as nonlinear problems with only single objective optimization formulation. D option is linear as well as nonlinear problems with single or multi-objective optimization formulation. Those who know the answer, you can type on chat box and then we will match your answer. Let me see who has replied. Yes, Div, A and D, very good. Your answer is correct. A and D are correct. So, evolutionary algorithm is one of the population-based meta-heuristic approaches, and this can be used to solve nonlinear problems with linear as well as nonlinear constants. So, this B option is incorrect because here only linear constant is shown, and C option is linear as well as with only single objective. It is also incorrect. It can solve multi-objective optimization problem. And the demerits of this meta-heuristic approaches are that this convergence is not granted, but it can solve this single or multi-objective optimization. Now let us move to the next problem. So in the next problem, in distribution system network reconfiguration, the primary objective of switching operations or altering the topology of the electrical distribution network is to, and the options are to control the voltage level at critical nodes, to reduce the number of substations being operated in network, to minimize the network power losses and improve the reliability system, and to optimize the physical layout of distribution lines. You can give your answer in chat box. I am coming in 1 minute. Yes. Div and Guddu, both of your answer is correct. C is the correct answer. Minimize network power losses and improve the reliability of system. So in distribution system network configuration, the primary switching operation or altering the topology is to minimize the network losses and improve the reliability of system. Now let us see the next problem. Which of the following statement is correct about the sectionalizing switches and their functionality in the context of distribution network reconfiguration? And the options are: A option is they are normally closed and are used to control the overall voltage levels in the distribution network. And B option is they are normally closed and used to optimize power flow in the network. C option is they are normally open and are used to regulate the frequency of the electrical network. And D option is the last option is they are normally open and are used to optimize network power flow for minimizing energy loss. Yes, and Guddu and Deep, both of your answer are correct. B option is correct one. Very good. So we know that sectionalizing switches are of normally closed type. We have gone through this in tutorial session 2 also. Sectionalizing switches are of normally closed. Normally closed means NC type, while tie lines or tie line switch are of normally open. We have seen its operation also. Sectionalizing switches are used in the same feeder to connect the branches, to connect the laterals, while tie line switches are used to connect the one feeder to other feeders. Therefore, it is of normally open type. And these tie line switches is used in the emergency condition. We can take the power supply from the other feeders through these tie line switches. While sectionalizing switches, we are using this fault condition to remove the faulty part without interrupting the power supply to the healthy part. So sectionalized switch it gets open when their fault happened, and this tie line switches get closed whenever we want power supply from the other feeders. So if you see from the options, they are telling normally open. So from options, you can first just separate these two options. So options C and D, where they are telling these are of normally open type. Now there are two options where they are telling are these are of normally closed type. A option, they are normally closed type and used to control the overall voltage levels in distributed networks. So it is not controlling the voltage level. We are not applying any control technique here. B option is that they are normally closed type and used to optimize power flow network. Yes, it is correct. Means sectionalizing switch, you can optimize the power flow in the network by opening the switch and closing by changing the position of by changing its status. So they are normally closed and are used to optimize the power flow network. So B option is correct. Now let us come to the fourth number problem. A distribution network is enabled with dynamic network reconfiguration to minimize energy losses and switch operation. Which of the following is not explicitly considered a constant in the optimization? And the options are power balancing and thermal limits of distribution lines, frequency deviation of the network from the nominal value, voltage deviation at network nodes from the nominal value, and D option, last option is redundancy of the network and continuity of power supply to the loads. Yes, yes. I got Dev, your answer. I think you have replied or not. So this here you have to tell that constant. Which of the following is cannot be constant for the optimization problem? The simple question that which of the following is not explicitly considered as a constant in the optimization problem? So you have to pick one option. Anyone? Div and Gurdu. Yes, B is correct. Very good. Because from the constant, you can see what can be the constant. We have seen so many constants. The power balancing is the security constant. Thermal limit is also a constant. So this is true. So these are constant. Here they are telling that which cannot be constant, not explicitly considered a constant. While this frequency deviation of the network from the nominal value cannot be constant, we are not taking frequency deviation. Frequency is a global variable in the network, while this voltage is a local variable in the network. That's why we don't take this frequency as a constant in the optimization problem. So frequency is a global variable while voltage local variable. There we take this voltage deviation as a constant. So here you can see this voltage deviation at network nodes from the nominal value. Yes, voltage deviation here you can see this is of inequality constant. So this is also a constant. Redundancy of network, yes, it is of equality constants, and the continuity of power supply that loads, yes, this power balance should be there or continuity power supply. So D option is also a constant. We have to we don't set off any area while doing the reconfiguration. We cannot set off any area. We don't interrupt any. We don't interrupt power supply to any part of the network. So this frequency deviation is the correct answer because it is not a constant in the optimization problem. Now let us see the next problem. So here a distribution Okay, I think again network problem is on my side. This Wi-Fi of college get interrupted. So now for this problem, the correct answer is nonlinear constant problem with mixed integer decision variables. So D the correct answer. Means when we have to determine this optimal substation size and optimal feeder routes, the optimization problem can be of nonlinear constant problem with mixed integer decision variables. Now let us come to the next problem. Which of the following is not true about the Pareto based optimization of distribution network? And the so question is which of the following is not true about the Pareto based optimization of distribution network? And the options are: A option is Pareto based optimization aims to find a set of non-dominated solution in the objective space. B option is Pareto based methods only work for mono objective optimization problems and struggle with multi objective problems due to conflicting objectives. C option is Pareto front is a set of optimal trade-off solutions where improvements in objective come at the expense of worsening other. C, D option is, and the last option is Pareto dominance principle is used to compare solution in terms of their superiority concerning multiple conflicting objectives. So here you have to take care of that it is asking not true. So it is asking not true. So which of following is incorrect? You can give your answer in chat box. We have discussed this Pareto based approach. We have seen the Pareto solutions, Pareto front. Now it is showing the slide, Div. Okay. Okay, Div, your answer is correct. This Pareto based methods only work for mono objective optimization problems and struggle with multi objective problems due to conflicting objectives. So this is incorrect because this can work for this is mainly to multi optimization problem and does not struggle with multi optimization due to conflicting objects. And the first option is this aims to find a non-dominated solution. Yes, it is correct. And this Pareto front is set of optimal trade-off solution where improvements in one objective come at the expense of worsening other. It is correct where we have seen while when we are dealing with there is trade-offs solution. This Pareto dominance principle is used to compare solutions in terms of their superiority concerning multiple conflicting objects. So these work for multi-objective problems where these objectives are conflicting with each other. This and and this where we need to compare solution in terms of their superiority concerning these multiple conflicting objectives. So therefore, B is the incorrect option. Therefore, B is the correct choice because they're asking which of the following is incorrect about the Pareto-based approach. So let us see the 7th number problem. Which of the following is a performance indicator considering reliability centered distribution network expansion planning? So options are reliability of the network, percentage feeder voltage drop, system average interruption duration index, and the last option is number of substations in a given area of a distribution network. Yes, Divi is saying B. No, it is incorrect. Any other one? Guddu? Here he asking about reliability. So just think about which can denote the performance indicator for reliability. Percentage feeder voltage drop does not tell about the reliability. Voltage drop just like a power quality problem, or it may leads your system to unstable. Your system may go into instability if more voltage drop happens in the area. Yes, Dev, your answer is correct. Very good. Because it is just like CLLI, you were asking at the time, it is just like a performance indicator. So CLLI is also a reliability index that Sanjeev Ganguly sir has introduced in his paper, in his research paper. So this one is well known system average interruption duration index, by which you can tell that how this how your approach, how your optimization solution improved the reliability of the network. So this is a system average interruption duration index in the correct answer, Saidi. Now problem number 8, particle swarm optimization is, and the options are used to solve problems with only continuous variables. I think there is a mistake here. This should be used to solve problems with only solve optimization problems with only continuous variables. B option is deterministic approach with a proper mathematical structure for optimization. C option is only heuristic technique whose convergence is granted. And last option is a meta-heuristic technique that can be used for problems with continuous as well as binary variables. So let me see who has responded. So Dev is saying A. No, I don't know how you are doing mistake. So I will show you. I will show you this slide, then you will able to answer. So this one is good, uh, good table, good. You can say this. Here, sir has provided this all the optimization approaches. Yes. Now you give me the answer. Here, if you see this, where this particle swarm optimization lies. So it lies under this population based meta heuristic approaches. This is PS. Now you give the answer. Can PSO handle binary variables? Yes. Yes, it should handle. Why not? It can handle binary variables also. And it is this mathematic based approaches. So it is one of the most, what you can say, it is one of the most robust approach. Means it can be applied, means like we have seen that it can be, where that is. So it can handle non-linearity, non-convexity, non-differentiable. So there are so many merits of this meta-heuristic, population-based meta-heuristic approaches. So why it cannot handle these binary variables? So it can handle binary variables also. There are several benefits of meta-heuristic, population-based meta-heuristic approaches. They can handle non-linearity, non-convexity, non-differentiability effectively. So yes, correct. D is the correct answer. Very good. So here in the first option it is written that with only term is like they are telling about the limitation or demerits of this particle swarm optimization. But this, if you see this lies in this population meta-heuristic approach, that has so many advantages about its range. It can be widely adopted in many means like in tough optimization function. So therefore it cannot, A option is not correct. Now let us come to the 9th number problem. I hope you all will be able to give the right answer for this question. And the question is that maximum value of contingency load loss index implies. And the options are, A option is maximum reliability of the network, B option is minimum reliability of the network, C option is optimal power for the network, and D option is maximum load interruption due to a single branch failure. I hope I got some of the answer. Div and Guddu, B is, they're telling B. Yes, B is correct answer. Means CLLI is inversely proportional to reliability. So minimum reliability of the network is correct. Because CLLI is inversely proportional to reliability. If CLLI is high, then the burst reliability, while CLLI is 0, then it is most reliable. So B option is correct. That is minimum reliability of the network. Zero comes then best reliable network, while 1 denotes worst reliable network. Now let us see the 10th number problem. Which of the following objectives is not considered in the expansion planning of power distribution networks? And the options are optimal feeder routes, size and location of substation, and distribution system. C option is distribution system reliability, optimal reactive power from the compensators. So this is the last problem for today's session, and then we can revise the previous year, means previous year has some problems if we have time. Yes, Divya, good to both of you are correct. D is the correct answer. Very good. So optimal reactive power from the compensator is not the correct answer. Other one, optimal feeder routes, yes, it is the objective in the expansion planning. And size local substation also objective in the expansion planning. Distribution system reliability is also in the expansion planning. I just want to ask you here one question. If you can answer, means what are the difference between aim of power distribution planning and power distribution reconfiguration? What is the means like major thing that by which we can differentiate this power distribution planning optimization problem and the power distribution reconfiguration problem? Dev or Guddu, either of you can answer. So if you talk about this power distribution planning, what is the aim? The aim of power distribution planning is to design brand new power distribution network. It's like to design feeder routes and branch connector sizes. And the challenge is to allocate optimally or place sectionalizer or tie line switches in the power distribution network such that power loss minimized or reliability maximized. Power loss minimization and reliability maximized. So here in power distribution planning, you are developing a brand new network, and the challenge is to allocate or place the sectionalizers or tie line switches while maintaining the while this minimization of power loss and enhancing the reliability. And on the other side, in the power distribution reconfiguration, you are playing with the switches. Means like you are not developing in a new network. You are playing with the switches in the existing network. Means like here, aim is to select the status of sectionalizer and tie line switches while maintaining the readability and some other constants like power balance and voltage limit constants. And here we are playing with switches, and the aim is to just select the status switches or minimizing the switch operation. So in the power distribution reconfiguration, we are not developing the network. We are not developing brand new network. We are not expanding the network. While in the planning, we are developing brand new power distribution network, or we are expanding the power distribution network such that we can optimally locate or place the sectionalizer switches. While in the reconfiguration problem, we are playing with the switches. Means we are seeing the in the optimization problem, the aim is to decide the status of switch and minimize the switching operations. So that are aim in the reconfiguration. While in planning, we are allocating or placing the supplier switches or tie line switches optimally in the network. That is the major difference. So that's all for this tutorial session. And if you can see the 2023 assignment problems I have attached, and you can just look on this. That will be helpful in your final exam. That will be very useful in final exam also. And this will help you in this solving current assignment also, because some questions may be repeated in this current assignment. So about constraint, so here
Current assignment is asking in the final exam, sir. Current examination of questions are asking in final exam. So,
no, it is not. It is not. It depends upon the what you can say. It depends upon the course instructor. But very less chance the same problem will be asked. This similar type,
chances of 2023 or 2024 type of
similar
question.
similar type will be asked, because the question has also limitations. You cannot generate so many new questions. So if
That is
you
multiple type questions. Only data changes value and questions are same asking in the exam.
yeah, that will be sure. Means, how means, there will
Third,
be certainly some questions are just data will be changed, and the questions are similar in nature. Not this exactly. If you see with the word and sentences, that not be exactly same. They just modify the sentences and modify the words.
okay, sir.
But don't miss like too much confident. Miss like this will be asked. I have given so many NPT exams in that they have asked truly new question. Means based on the concept they have told in the classroom. But like in general, I am not saying with means like 100% that will true. But in general, what I see that they will be just manipulate the assignment problem only. But it is not.
Like as assignment type of questions asking, sir.
Yeah, means the assignment problem type, similar type problem will be asked.
Okay, sir. I prepared all assignment or numerical type questions. Prepare for solving different value and solve.
Yeah, you should just make short notes, means like what are the formula you need to remember, what are things that will, because preparing for exam is another thing and understanding the concept is also another thing. If you have know the concept and so solving the assignment problem, you will certainly uh, get good
Yes,
marks.
I will. I video lecture. I am daily basis. I am uh, seeing and different types of questions asking. I am practice every day.
Yeah, yeah, that will be good. You are just doing this course for how, what means like any requirement is that, or is just for enhancing your knowledge?
Concept is the more important, na, sir.
No,
Concept
no,
and
I'm just asking, like some people are doing course like they can include in the coursework for PhD, or they can get some credit in BTech or MTech, and some
yes,
people
I need
required by the
for
company.
PhD credit work for, sir. I need for
In
PhD.
which college you are? In which college you are studying?
NIT Patna, sir.
Oh, you are from my area.
Yes, sir.
I also did BTech from Bhagalpur College of Engineering.
I come from, sir, Darbhanga, my
Okay.
hometown. I join in PhD in NIT Patna, sir, 2020-24. This is my second semester.
Okay. Okay. Nice. Okay. Who is your supervisor?
My supervisor is, sir, sir,
You are a regular or you're part time?
sir, part time, sir.
Okay. Good. And means this is your second semester that maybe
Trilochan,
allocated.
Dr. Trilochan, sir, sir.
Okay.
Dr. Trilochan, sir.
Okay.
My
Yeah.
memory, something,
This is your first time or your second time in NPTEL course?
no, sir, this is second time. First semester, I have joined four subject, and
And then you are well familiar with how they are asking the exam. Why I means those who are giving the first time, they will be have some doubt. But those who have given already for exams, then I think you are well familiar, right?
yes, sir, yes, sir.
You know that they are mainly most of the time they will ask mainly from the assignment type problem. And if the it depends totally on instructor, whatever I am saying, that is not be truly followed. they they may ask very tough question, they may ask, but the syllabus is same. They will ask syllabus, ask for syllabus, they will ask from the never you have seen that type problem, but they may ask. But if you have better concept and if you have gone through the assignment, you will certainly get a elite plus gold certificate, that I will know. But this course is, I don't think you
This
will face
semester
that
I
much
have,
problem.
sir, six credit needed, sir. One is I have joined in EV vehicles and electric motor drives, and another is this subject I'm joined, sir. So, and another also I have joined in control engineering. Three subjects, but I have need only 6 credits, sir, for PhD coursework. So I
Okay,
am
good.
dedicatedly, sir, prepared. So daily
Yeah.
basis.
Yeah.
Concept
How is your performance in assignment? You are getting good marks or what?
good marks, sir. 9, 10 every assignment, sir.
Okay.
Mostly out of 10, 2, 3 assignment, 9 out of 10, sir.
Okay, that's very nice. Means if you are scoring in assignment, then certainly just revise carefully and just go through concept.
Yes, sir.
Just you
I
can
have
also watch the lectures, and
I
then
have I have
you will
assignment
certainly
solving
get.
before assignment solving. Uh, I have read your video lecture and then solving the uh, helpful for uh, assignment solving, sir.
Okay.
Before solving.
Where you did BTech? Your BTech?
BTech, sir, Rajasthan Technical University, Kota, sir.
Okay, from Kota. There are so many colleges, na? Means from
Yes,
Kota
yes, sir.
only.
Rajasthan Institute of Engineering and Technology, sir. From Kota.
Ah,
And my MTech is the RGPP, sir. And and another one, my degree is from Jawaharlal Nehru Vishwavidyalaya, postgraduate diploma in Big Data Analytics, sir.
okay, okay,
After
nice,
I am
great.
joining in MTech from Rajiv Gandhi Pradhyogiki Vishwavidyalaya, sir.
Great. Okay, these are another things anyway. So you just, I will suggest that just go through this 2023 problem also.
Sir, this semester anyhow, sir, I have good marks achieving, but my if I am not, I didn't achieve, then PhD, sir, coursework not completed, sir. So important uh, this final exam paper, sir, for me.
Yeah, you certainly will get it. I hope so. Don't worry that much.
Okay, sir. Thank you, sir.
Welcome. So these are about dynamic programming and then Pareto based multi-objective optimization. If there's something new, then I will just tell you. Otherwise, you quickly go through these questions.
So this type of question, sir.
Yeah.
Should want
So
the
these have been also asked in the previous year, 2023. Not in 2024 we have discussed. 2023 you can go through.
sir, this subject coming from this NPTEL, sir. Since coming since how many years from back?
Coming is 2021.
2021. This subject, sir.
2022. Sorry, 2022. Because
2020.
this.
So three year question papers are
Yeah.
conducted. 3 years.
Yeah.
So
So I have all
this
included
subject
the all the
every
questions.
two semester in a year, no, sir. Yeah, only for this
No, no, only out semester.
odd semester.
Yeah. So I have included all 3 years problems. Don't
Yes,
miss,
sir.
just go through it. It has started from 2022. So I was TA from 2023. So I was just, this is my third time I'm doing this TA in this course, PMRFT in this
So
course.
2022 question where is coming? कहाँ से मिलेगा, sir?
I attached with this PDF. I am attaching with this PDF.
Yes, sir.
Whenever I am uploading, I am attaching that. So you
In
can
this
go
there are
get.
2022 and 2023 questions also attached, sir. In the
Yes, yeah. In all my tutorial slides, all the questions are attached.
yes,
Because I was doing TSC from last 3 years.
sir, previous assignments, sir, back to one to eight, 9 assignments. Mostly questions coming from numerical type, sir. So I have a study in formula and concept concept solving patterns for the solution. So I technique same techniques are applied. Then mostly questions are solved, sir. So
Yeah.
this type of in the final exam, uh, this type of questions asking, sir, same patterns.
Yeah, same pattern. That's I told you. Na. Means like the similar type will be asked. Means most of the chances are there. I'm not 100. I'm not telling anything. Means 100% sure
100% not sure it is, sir.
because
But
because exam
preparation
is there.
preparation is the I am only TA lecture, and the Ganguly sir's videos are lectures. So I'm thoroughly study, sir. One
Yeah.
day by day, sir. So it is the sufficient, na, sir.
Yes. Yes. It's sufficient. What means you have to go through this. Means only
Lecture
the materials.
Ganguly sir material lecture notes is the I am PDF format. I am xeroxed and thoroughly and underline the important points.
Yeah. Yeah. You
This is
can
sufficient, na, sir.
just do that. Yes. I think it should be sufficient.
So,
Okay. Good. And any
thank you, sir.
other things you can mail
Next
me
Sunday
also.
I am with sir.
Yeah. Okay. If any other doubt, you can ask. Otherwise, we can close
So,
today.
if any doubt, sir, then I am number of doubt I am collecting. The next Sunday I am asking you, sir. Next Sunday
You
it will.
can you can mail me also. Na. I am just
Yes,
put
yes,
in
sir.
my initials.
Mail ID, sir.
You can mail me. You can also text me on WhatsApp if you want.
So WhatsApp number, sir. Mail ID. I have no idea. So your mail ID and WhatsApp number, sir.
sahilgaurav@iitg.ac.in.
Sahil Gaurav. 1 minute, sir. Sahil
At
Gaurav.
the rate iitg.ac.in.
Okay, sir. And numbers showing me, sir. Mobile number, sir, showing on set time, sir.
Written in the chat box. You can go through it.
Okay, sir. Okay. 856011.
So Devi is asking, what is the relation between reliability and installation or commission cost?
Okay, sir.
So
Thank you.
okay. So these are conflicting with each other. What you are asking, Dev, they are conflicting with each other. Means like reliability, if you improves, then certainly this installation cost will be very high or commission cost will be high. And if this reliability version means that means your installation or commission cost is lower. So we have to trade off between these two things. Means don't enhance too much reliability so that our installation cost is also very much high. Means like reliability is also adequate and installation or commission cost is also adequate. So there is trade off in these two functions. So we have to make trade off between these two functions in multi-objective optimization problem, right? Means like certainly you can understand. Means like if you make anything with too much level, you have to invest too much, and we cannot put too much money in a certain. We cannot invest that much amounts of money. So we have to just put adequate amount of cost for installation and commissioning, and we have to have certain reliability. We have to certain range of reliability, so that there is trade-off between there is compromise in both the things. Another thing, Dev, there are two attending only. I means like I think you both two are only most sincere people, and happy to see that both you are attending the lecture from the first. I think Gudu attended later part, but Deep is the only candidate that she is attending from the first tutorial.
No, sir. I have 2 times attended, sir, in your lecture, sir. Continue.
Is you started from the
Last,
first tutorial?
no, sir. Two times, sir. Last Sunday and today I have. There are two times I am attended, sir, your lecture.
Oh, that's what I'm saying. Okay, nice to means there are 2 sessions left, so I hope you all attend that, and then we will close. And then this course will be ended. Okay, thank you for attending session, and then we will meet on the next tutorial session at the same time.
Okay,
Thank
sir.
you for joining.